In this segment, we're going to be covering the IPM program strategies. We're going to cover the difference between monitoring and sampling. And we're going to recognize and understand the different sampling techniques for insects. So the previous two segments, we've covered what integrated pest management is. We've covered what a pest is. We've covered why and what we do for integrated pest management. Now we want to cover specifically what you're going to be doing in the field. And most of the time, that's going to cover monitoring and sampling. IPM programs, a pest management program, consists of a set of strategies. These strategies differ by crop, location, and pest complex. What I do in corn is not going to be the same as when I'm sampling for pests in soybeans. They're unique to the management unit, so each area is going to have a different sampling program based on what pests are going to be in that crop and the crops that you are growing. For most agronomic crops, an IPM program consists of monitoring and sampling, which we're going to cover today, identifying, consulting control action guidelines, and applying tools and tactics. So the most important part in any kind of IPM program is monitoring and sampling. Monitoring involves regular visits to a location and systematically checking and recording observations. When I plant soybean out in the field and I'm doing my different research plots, I'm going and I'm checking those weekly. These observations could be just crop status, how does the crop look, crop health, soil moisture, pest presence and abundance. And for insects, we really need to figure out a way to be able to monitor for those, and that's where the sampling part comes in. These observations should be recorded because they can provide a historical record. You want to be able to know what pests are occurring every year in that field and what kind of sampling techniques you're going to be using to understand the pest levels. Sampling. What is sampling? It's a quantitative evaluation of pest population numbers. We need to be able to get a set of measurements taken from a certain part of a population. So you don't want to sweep the whole field. You don't need to sample the whole location, but we need to be able to sample effectively to be able to understand what pest levels we have throughout that whole field. So our sampling universe, or in other words, is the boundaries of the sample area. This could be the whole field in some parts of the program. They could be a smaller area of the field or a certain plant in the field. This is often a subset of individuals to make a statistical population to estimate characteristics of a whole population, and each observation measures one or more properties. So in other words, what you're doing is taking a segment of a field, determining how many insects are in there. First, one of the easiest ways of sampling is this visual sampling. It's the most common sampling technique. You're going to walk through an area. You're examining specified number of plants or plant parts for pests or their injury. And what you can do is you could just simply walk in the field and you're just looking for your different pests. You record presence of absence. Sometimes these may be timed counts. You're going to give yourself a couple minutes to walk through the field and record what you see. Where a good example of that would be speed scouting for soybean aphids. We're going to be providing a link to a video that shows you how to do visual sampling for soybean aphid, and this is important in the north central part of soybean production in the United States. Knockdown sampling. Here you're sampling pests that are easily dislodged but not easily moved. So what you're going to do is you use a sheet, a tray, a cloth of some kind, and this is often used. It's a collection device below the foliage and you beat above it, so you're knocking the insect pests down. Once again, you're counting number of pests and you're going to record those. One of the most common sampling techniques is the sweep net. All this is a shovel handle, a pipe clamp, muslin cloth, and what you're doing is you're sampling through the field, knocking the insects into the cloth, and then counting those. And we have a very good video that we're going to be linking to show you on how to use a sweep net. Once again, you're counting the number of pests and you're going to record those. A more intensive way of sampling is a vacuum sampling or a D-Vac. The pests are, once again, are not easily dislodged by shaking with a shake sheet or hitting with a sweep net, and they're more mobile insects. So what you're doing is, it's essentially a leaf blower that's been converted. Instead of blowing, it's sucking. So here you have a fancy vacuum that you're going to wear on your back, and you're going to suck the insect pests off. It's effective if the insects are small and can't be sampled with a shake sheet or a sweep net, but it's a very expensive tool and most people don't use it. It's primarily used by researchers, but it's a good example of what you can do to count the number of insects and pests that might be small and when the plants are young. Different trapping techniques, we're going to be showing a few of those. These are used to sample mobile insect pests. Insects are attracted by visual or chemosensory stimulation. We're going to be showing you some controls that have light traps or color traps. And here what you're doing is indicating pest abundance in an area, not necessarily specific to your field, but into the general area and what might be immigrating or emigrating from the different areas that you're sampling into. Sticky cards, these are very commonly used in greenhouse settings. We use those also in agriculture. What you have is a different color. In this case, what we have is a sticky card that's yellow, and it has a very sticky adhesive. Random insects fly into this. It's gridded, so you can count the number of insects per grid. And what you do is you change these weekly. Pan traps. Pan traps are, once again, here you have a trap that is a pan that has a different liquid, usually water, detergent, propylene glycol. The different bottoms of the trap could be colored green or yellow. This is going to be attracting to different insects. This is used for actively landing insects. So what I typically use these for are when we're looking for insect vectors of plant diseases, so the different plant viruses. Once again, you're changing these weekly and you count the number of pests and you record. Light traps, this is a very good example of a light trap here. This is a bucket trap. These are insects that are going to be attracted to light, primarily at night. Of course, the disadvantage here is you're using a UV light that's going to attract everything. If you've gone and gotten gas late at night at a gas station and you see a bunch of bugs flying around to different lights, that's what exactly going to be the same thing. You're attracting insects to this light. They fall down in the trap, and you're going to change these weekly and count the pests that you record. Of course, you're going to collect a lot of insects, and you want to make sure the ones that you're recording are just the pests. Pitfall traps. These are randomly captured species on the soil surface. It's a glass or plastic container in the ground with a mouth that's even with the soil surface. Insects walk along and they're going to fall in. Usually it has some kind of screen, so you're not collecting mice or snakes that might be falling into those containers. You just want to collect the insects. Again, change weekly, count the pests and record. And finally, pheromone traps. A pheromone is a chemical that insects are used to communicate to each other. These traps mimic sex pheromones. So what you're going to do is you put something inside a septum that is going to be releasing this chemical. It's usually some kind of male species attractant, or it's going to be an aggregation pheromone. You're going to count the number of insects that move into the trap and change these weekly and record. So we've covered what an IPM strategy for a location was going to be. We've covered the differences between monitoring and sampling, and we can recognize and understand the different sampling technique for insects. Thank you very much.